Hello everyone and welcome to my presentation. Thanks for attending and thanks to the organizing team of Conf42 Python 2021 for putting together this great event, for giving me the opportunity to present on it. Today I'm going to talk about delivering successful API integrations with Python, but before I do that, let me introduce myself. My name is Jose and I work as an independent contractor based in London. I work as a full stack developer, so usually working both with front-end applications and with backend applications as well. And for the past few years, I've had a long-term affair with microservices and APIs. So I've helped multiple clients build microservices architectures and to deliver API integrations. Along the way, I've made multiple mistakes, but I've also learned a great deal of things about what it takes to deliver a successful API integrations. As a result of this experience, I got the idea of writing a book about developing microservice APIs with Python. The book is published by Manning and it's currently available through Manning Early Access Program. If you want to get a copy of the book, you can use the following discount code to get a 35% discount from the price. I'm also the founder and creator of microapis.io. This is a website that makes it easy to launch API mock servers with one click, with no sign up or login required. All you need to do is copy the API specification in the input panel on the left side here on the website. This will trigger a validation process in the server of the API document. And if the document is valid, you will be able to click on this button to get the mock server. You will get a base server URL for the API, as well as a sample URL from the specification, which you can click to test that the server is working correctly. If you would like to connect with me, I try to be active in all of these platforms, in Twitter, GitHub, Medium, and LinkedIn. So if you would like to discuss anything related to software, microservices, APIs, or Python, please feel free to reach out to me in these platforms. So what's the agenda for this presentation? First of all, I'm going to talk about the complexity of API integrations. Why are they so difficult? Why it's so tricky to make them succeed from the start? Then I'm going to introduce documentation-driven development as an approach that can help us address the complexity of these integrations, and it can help us reduce the chances of failure. I'm going to show you how you can introduce documentation-driven development within your API development workflow by showing you a simple example of a to-do application with a REST API in front of it, which we're going to build with Fast API. We're going to test and validate the API with Thread, and we are going to run mock servers on the specification. I'm going to show you how you can include this process within your continuous integration server, and we're going to deploy all of this to Heroku. If you're interested in checking out the code for this presentation, it's available in my personal GitHub repository in the repo that I prepared for this presentation. So why are API integrations so tricky? If you picture the typical situation of a team working on an API integration, we usually have a team working on the API backend and a team working on the API client. The client can be anything from a front-end application running on the browser to a mobile app or another microservice. Typically what happens is both teams will be working in parallel, and at some point we release the API server, then we release the API client, we get them talking to each other, and the integration fails. And this failure can happen for multiple reasons, but very often it happens for simple things like a misunderstanding between the front end and the back end about what the format of a certain field could be. In this case, I'm showing the example of a misunderstanding with a date field, which the client is sending with slashes separating the different elements of the date, while the server is expecting dashes in the date field. These kind of errors are very common and they lead to all sorts of problems in our API integrations. Now, how do we end up in this situation? What takes us here? And obviously there is a large variety of factors that can affect the outcome of our API integrations. But when it comes to failure in communication between the front end and the back end, usually everything boils down to one of the following three factors. It can be the case that we don't have documentation at all, and instead of it, maybe we are working with JSON examples. Now, JSON examples are a very common resource when working with API integrations, but they don't offer sufficient coverage of the different payloads which are accepted by the server or which are returned by the server. So in these situations, it is very difficult for the API client development team to figure out the integration with the server. In some other cases, we have something like documentation, but it's not really documentation, or it's not documentation written in a standard format. What do I mean by this is we often end up writing API documentation in something like Google Docs, SharePoint, or Confluence, and we do that in non-standard formats. Or again, maybe we include JSON examples instead of actual schemas of the API. The problem with this is this type of documentation cannot be leveraged with the whole ecosystem of tools and frameworks that we have in the API ecosystem to make our life easier when it comes to maintaining and releasing our APIs. They don't help us to test and validate our implementations because it's difficult to manage our API integrations. Another problem we often find as well is we don't have a proper design stage of the API. So instead of having the front-end team sitting together with the backend team and talking about what the API should look like and what the requirements should be, often what the API is kind of an afterthought of the backend development process, and we end up releasing random URLs, and we end up with a messy collection of URLs and resources in the server, which are difficult for the client development team to understand and figure out how to use in the client. Now, to avoid these situations, obviously the best thing is to use proper API documentation. And what actually counts as API documentation depends on the type of API that we are using or the type of protocol. So if we are working with REST APIs, we want to use the OpenAPI specification formats. If we are working with a GraphQL API, that should be the schema definition language. And if we are working with something like gRPC, we should be expecting the documentation to come in the form of protocol buffers. So each protocol or type of API has its own format, and we should be making an effort to use that format, because then we will be able to use various tools and frameworks to make our life easier when working with these APIs. Now, what is documentation-driven development? So this is an approach that you may know already under different names. It's also known as design first, API first, or contract first API development. The basic idea is we design and produce the API specification first before we start working on the API client and the server. Then we build the API client and the server against the specification, and we use the specification to validate our code before we release it. Now, how does this work in practice? I'm going to show you with a simple example. Like I said before, I prepared a simple example of a to-do application. It's a very simple application that allows us to create a task. We can update a task, we can delete it, or we can retrieve the details of one task or multiple tasks from the server. The specification is written in the OpenAPI format 3.0, and it's written in YAML, but to get a better visualization of it, let's move on to a Swagger UI. So when working with API documents, I highly recommend you to use Swagger Editor. Swagger Editor makes it really easy to work with API documents because, first of all, it can validate the document. So if there is any problem with it, it will tell you where the error is and what type of error it is. So if you remove this line, for example, it tells us that there is a structural problem in line 13, and it tells us what kind of problem it is. So let's put this line back. Now the API specification is valid, and we can see that it has 5 simple endpoints. We can also see the payloads, the schemas for the payloads in this API. So we have a schema for error messages. We have a schema for the type of payload that we should be sending to the server when we create or update a task. And we have a schema for the type of payload that we will get from the server when we get the details of a task. Now, let me show you how we can leverage this documentation on the client side to run a mock server when we're working on the client. I'm going to show you 2 ways of doing it. One of them is running the mock server locally, and another way is running it in the cloud. To run the server locally, I recommend you to use Prism, which is a CLI tool built by Stoplight. It's a very powerful tool to run REST applications locally against the specification document. A Prism is an NPM package, so you will need to have NPM as well as a Node.js runtime available locally. And optionally, if you want to manage the dependencies with Yarn, you will need to have Yarn as well. The NPM dependencies for this project are listed in the package.json file. So we have the Prism CLI as well as Thread. I will introduce Thread a little bit later in this presentation. To install the dependencies, I'm going to use Yarn. All you need to do is run the yarn command, just like that. And after the dependencies are installed, you will see a Node modules folder available in your directory. So this folder contains all the dependencies that come with these libraries, as well as all the commands that are available with them. So the Prism CLI is available within this folder that is under bin and Prism. To run the mock server, we use the mock command available in this CLI, and we give it the path to the OpenAPI specification file. So if we run this command, the mock server is now running. The first thing we see in the logs is a list of the endpoints available in this mock server. So let's try out running a request and went against one of these endpoints. So I'm gonna do it with curl, and I'm gonna use JQ to parse the JSON payload returned by the server to have a nice representation of it. If you can see here, this is a list of items. Prism has included only one item in the list, but that's a perfectly valid situation for this API. And the payload contains all the expected attributes that we should be finding in these payloads. Now, this is how we would run the mock server locally. We can do it as well in the cloud. I'm going to show you how to do it with microapis.io. So what we need to do is we need to copy the API specification, and we need to paste it in the input panel, which is here on the left. We paste it here. First thing that the server is doing is validating the API. Now we can click on this button to launch the mock server. Like I said before, we get the base URL as well as a sample URL of the API. So if we click on this one, we get a payload with a valid list of items from the server. Let's try this in the terminal as well with curl. Let's clear the terminal and do a curl on this. We will use JQ as well to pass the JSON payload. And what we get is a list of items. In this case, we're getting more than one item, so the experience is a little bit different from what you get with Prism, but in both cases, we're getting perfectly valid payloads from the server. So this is a very useful approach to building API integrations. I'm currently using this mock service when I work with my clients in my current contract, and it's making our life to build the API integration so much easier, because we can simulate the interactions with the server while the endpoints are being implemented, and we can get simulation of network latency issues. So obviously there's some data that is not going to be available within microseconds. It might take a little bit longer than that, and we can implement the API client in a way that is able to handle these situations. Now, this is how we leverage the benefits of documentation-driven development in the client side. Let's see how we benefit from this in the backend. So, like I said before, we're going to build the API with Fast API. For those of you who don't know, Fast API is a highly performant web API framework for Python. It's a very recent project, but it's one of the most popular Python projects at the moment. It's very well written, very well designed. It has a very intuitive interface, and it is extraordinarily well documented. So if you haven't checked out Fast API yet, you should definitely check it out. I think it's without any question the best API development framework for Python right now. Now, Fast API works with Pydantic to validate data payloads in the server. So Pydantic is another very popular library in Python for data parsing and validation. And as you can see in this example, the way we define the validation rules for our payloads is by using type hints. So this gives us a very Pythonic and very intuitive way of defining the validation rules for our models. So let me show you the dependencies for the app. They are listed in a pip file. We have a couple of development packages. We have thread hooks, which I will introduce a little bit later. We have also data model code generator, which is a library that is going to help us translate the OpenAPI specification schemas into Pydantic models. And we have a couple of production packages. Obviously, we have Fast API, which is going to help us build the API application, and we have UVCon, which is going to help us run the web server. Now, for those of you who are not familiar with it, Data Model Code Generator is a library that helps you translate any kind of JSON schema specification into Pydantic models. It is extremely useful and very powerful. And in most cases, I would recommend you don't write your data models manually. If you have a specification at hand first, I recommend that you use this tool to do the translations, since it can help you avoid many mistakes in the translation process. So first things first, let us stop the mock server of Prism that we started before. Let's clear up the terminal and let's install the Python dependencies for this project. So we do that because we have dev dependencies. We do that with the dev flag. So our dependencies are already installed, and now we have to activate the pipenv environment. We do that with pipenv shell. The environment is already activated, and now we can start working on the project. Like I said, the first thing we want to do is we want to generate the Pydantic models. So we do that with the following command, which is data model code gen. We need to give it the input, which is the OpenAPI specification file, and we need to give it an output, which is the file where we want to see the schemas written to. So we run the command, and the schemas file is already available. So this is the file. It contains some metadata, like the file we use to generate the models, as well as the time when we run the command. So data model code generator makes an excellent job at translating the OpenAPI schemas into Pydantic models. But if we look closely at the file, we see there are a couple of duplications. So in particular, these two classes are duplicated here below, and really they should be the same. So let's delete these two classes to make maintenance easier in the future. And let's rename these classes here. If you're not familiar with Pydantic, you may find these ellipses here a little bit confusing. This is just a way of telling Pydantic that a field that has been declared with the field class is required. Otherwise, any field that is directly declared with a type hint is supposed to be required, unless you mark it explicitly with the optional type hint. So now we have our Pydantic models ready. Let's move on to the API file. So I have created the API endpoints for the API in this file in api.py. The first thing we have is a list for the to-do items. So to keep things simple, I've decided to use an in-memory list representation of the data instead of a persistent storage. If you're familiar with Flask, the interface here will look very familiar. The way we define the endpoints is using decorators on the application object. The decorators are named after the HTTP endpoint for each endpoint in the API. So this is for a get endpoint on the to-do URL path. In cases where the API endpoint returns data for the user, we want to use a response model class that FastAPI can use to validate the data that we are sending to the user and also to serialize the data. In cases where the API endpoint returns a status code, which is different from the standard 200 status code, we can specify that in the status code parameter. If the API endpoint accepts a payload in the request from the user, we can also tell FastAPI which is the Pydantic model that should be used to validate the request payload. And in cases where the URL contains a parameter, we can also tell FastAPI what is the type that should be used to validate the URL parameter. So this is all about the API layer. To initialize the server, all we need to do is create an instance of the FastAPI class. We are running here in debug mode, and we are also importing the API routes into this file to load them at the startup time. There are other ways of loading the API views. So if you are familiar with Flask blueprints, FastAPI has a similar concept to them. And that's really the type of approach you want to use if you're building a production application with FastAPI. In this case, just to keep things simple, I'm using this approach. So we have the API implemented. Let's now run it with UVCon. So to run the application with UVCon, we have to give it the path to the file with dot notation, and within the file, after a colon, we have to tell it which is the variable that represents the server. So if we run this command, we get the API server running, and we can check it out in this URL. So let's go ahead and visit that URL. Now, if we visit the to-do endpoint, for example, we will get an empty list. FastAPI is capable of generating an OpenAPI specification from the implementation and also a Swagger UI visualization of the API. So let's go ahead and visit that URL. And this is the Swagger UI for the API that we have written in Python with FastAPI. With this, we can already interact with the server. So if we run the get endpoint, we get again an empty list. So let's go ahead and create one item to verify things are working fine. So if we execute this, we get a valid response from the server with a 201 status code. So if we run the get endpoint again, now we have one item in the list. So the API seems to be working as expected, and typically now we would write a bunch of unit test cases to make sure all the rest of the endpoints are working fine, and we cover some edge cases in the API. Now those unit tests are fine, but in addition to that, I encourage you to use as well a proper API test framework, because usually unless you are ultimate expert in APIs, I can guarantee you that you're going to miss some edge cases in your test suite. So in this presentation, I'm going to introduce you to Thread. There are some other test frameworks as well, which you can explore. But Thread is a classic API test framework that will get you covered with all possible edge cases when it comes to API communication. So it will test the payloads of your server. It will test the return status codes and the payloads for those status codes. So a combination of unit tests that make sure that the application is behaving correctly in combination with a test suite run by Thread will get you covered with your API applications. Now, how we run Thread? First of all, Thread is an npm package. So I already listed before Thread in the package.json file that I showed you before. That is here. So when we run yarn to install these dependencies before, we already installed Thread. And to run Thread, what we need to do is bit by bit, that is the Thread CLI, together with the first input is the path to the API file that we are going to use for validation. The second parameter is the URL where Thread will be able to run the tests. And the third parameter here is, with the server flag, is the command that Thread needs to run to make sure that it can launch the web server to run the test suite. So if we run this now, Thread is now testing the API, and it's telling us that 5 tests are passing, but 3 are failing. Now let's have a close look at those tests that are failing. So this one, for example, is the delete request on a specific resource. That is failing. The put request on a specific item is also failing, and the get request on a specific item is failing as well. All the other requests are fine. This is just a repetition of the request that I mentioned before that was failing. So if you think about it, what is failing here is those requests that target specific items in the server. So when Thread is trying to perform an operation with an existing item, it is failing. And now the reason why this is happening is because Thread is using random IDs to test the API. It's using one ID for creating the resource, and then it's using a different ID to retrieve a resource or to perform operations on it. Obviously, random resources don't exist on the server, so we have to customize the behavior of Thread in such a way that it always uses the same ID that was returned when we created a resource on the server. We can do that with Thread hooks. That was the dependency that I included here. This plugin allows us to customize the behavior of Thread and to keep track of the state of the test suite. I've prepared a file with a collection of hooks here that affect the behavior of Thread. The first thing we are doing is creating a dictionary, which we are going to use to keep track of the state of the test suite. And then what we are doing is telling Thread that when we create a task using the post methods, we need to save the ID of this task. We are going to use this ID in the following methods that perform operations on a specific task. So when Thread wants to update a task, we are going to tell it to use the existing task ID that we obtained when we created the task. And when we delete the task or get the details of the task, we're going to tell it to use that same ID. So the file is already available, and to use the file, we used Thread with the following parameters. We need to use the hook files flag and point it to the path of the file that contains the hooks. We have to tell it in which language the hooks are written. So in this case, we wrote the hooks in Python, so we just simply tell it that the hooks are written in Python. If we run this command now, the test suite is passing fine. Now, no errors. 8 tests and the 8 tests are passing. Now, we have verified that our API implementation complies with the API specification file. We would like to make sure that this test is run every time we make any changes to the code, and the code is validated before we make a release. How we do that? We can do it by incorporating this test suite in our continuous integration server. So I've prepared a Travis file for this exercise. So the Travis file contains instructions about how to install thread to run the test suite. It tells the server also how to install the Python dependencies. It tells the server what's the command that has to be run to run the test. And we also provide some deployment configuration so that this can be deployed into Heroku. We are also telling the server to use the correct version of Python so that pipemp doesn't complain. So to test how this works, we are going to make a commit here. We are going to commit the changes we made to the schemas file before. And now we are going to push this. To make it simple, I'm going to push directly to master. So git push origin master. I think we are in master. Yes, so git push origin master. So this is now in GitHub, and Travis is going to get a trigger, a notification when at some point to run the test suite and then deploy the code if it is valid. So we just need to give it a moment. Now the build is starting. We're going to follow the logs. So Travis has run the thread test suite against the application. The tests are passing, and therefore Travis is moving on to the deployment stage of the continuous integration process. We can monitor the deployment process in Heroku, and that is already triggering the deployment. It's about to release. And this is the URL that we can use to visit the application. Just need to leave it a minute. Okay, so the build is finished now. We can now visit the application on this URL. So let's go ahead and do that. We're gonna visit the docs endpoint that I mentioned before. Contains the Swagger UI to interact with the application more easily. So let's go ahead and do that. And this is the Swagger UI. Now, if we try the get endpoint, the list is empty, obviously, because the application was just released and we are visiting a new instance of the app. So let's go ahead and create a task. We do that. We obtain a successful response, and now we execute the get endpoint again, and we have one task in the list. So the server was validated, it's working as expected. At the same time, the client development team has been working against the same specification. So things are never 100% certain, but if we follow this approach, we can be fairly certain that at least when it comes to API communication, both the server and both the client and the server will be talking to each other in the same language. So this is really everything I wanted to introduce in this presentation. Thanks for listening. Again, if you're interested in connecting with me, please do so in any of these platforms, on Twitter, GitHub, Medium, or LinkedIn. And if you want to get a 30% discount code on my book, feel free to use the following code. Thank you and have a great day.